Today we're going to be discussing elementary reactions. So these are the key terms you need to know for this unit, including rate law, reaction rate, first order reaction, second order reaction, half-life, and elementary reactions. Elementary reactions are a single-step process in which molecules collide and react to form products. Chemical reactions happen over multiple steps, not just one, and these are shown through elementary reactions. The important thing to remember about chemical equations is they don't tell us how reactants become products, but it gives us a summary of the process by showing smaller steps. Additional information you need to know is the molecularity of a reaction. Unimolecular is when one reactant is included. Biomolecular is when two reactants are included, and rarely you will see termomolecular, and that's when three reactants are included. Finding rate law. Let's find the rate law for biomolecular reactions. To write the rate law for these equations, we can use this as our example. A plus B to products. Rate constant times concentration of A. And since these are elementary one-step reactions, you can use the coefficient and turn it into the exponent. Reaction order. How the concentration of reactants influences the reaction rate. Zero order is when increasing concentration of the reactant, but the rate doesn't change. First order is whatever you multiply by reactant's concentration is the same as multiplied by the rate. Second order is whatever you multiply by your reactant's concentration is squared to your rate. Let's solve the order of reaction using this table. So to do that, we have to compare the rates, and we can do that by using this formula in the green. We see that the reactant's concentration is multiplied by 2, and the concentration is squared to the rate, meaning it is second order. Next, we're going to observe an energy diagram. Activation energy is the energy required to go from reactants to products. Up is higher, and to the right means later in time. Higher activation energy means slower reaction, while lower activation energy means a faster reaction. Catalysts lower activation energy by increasing reaction speed. Additional information is a transition stage, where right here basically will confirm the reaction will take place. Anything lower won't happen. Another thing is delta H. That is the difference in energy between reactants and products. Products sit lower is exothermic, and products that sit higher is endothermic. Let's try to figure out which one of these graphs is showing endothermic and which is showing exothermic. We know that exothermic shows products sitting lower, so the left would be exothermic, since the reactants are higher than the products. All we really have to look at is the starting point of these two graphs. Here are the extra resources for this unit.